If subtraction is written backwards when you're trying to reduce your fractions, factor out a negative. When you factor out a negative sign, write the subtraction switched around. So in this first example, x squared minus 1 divided by 1 minus x, I'm going to factor the numerator because of that subtraction sign. It's a difference of perfect squares, so it's x minus 1 times x plus 1, and the denominator does not factor, so I just simply put parentheses around that. Now if I want to reduce, I have to find a common factor with the numerator and the denominator. And x minus 1 is not the same thing as 1 minus x. Consider numbers like 3. If x had on the value 3, 3 minus 1 is positive 2, but 1 minus 3 is negative 2. So it's not the same value. What we do in that kind of a situation is we'll factor out a negative sign. But when you factor out a negative sign, that allows you to switch the subtraction in the other order. So where it said 1 minus x, now I switch it and it says x minus 1. Now this 1 minus x is the same factor as this x minus 1, so I can reduce. I'm left over with this negative sign that's just floating in the denominator. So it's best just to write it up in the numerator, and therefore there's nothing left in the denominator, and we're done reducing the fraction. In this example, x squared minus 2x plus 1 divided by 1 minus x, we would factor the numerator again because of the addition sign and subtraction sign. So I'll use two sets of parentheses since this is a trinomial, and I've already checked there was nothing common to every term. And I'll break down the last term and check the signs. They're both the same. They're both negatives. And then make sure that that works. A negative 1x is in fact a negative 2x. The denominator does not factor 1 minus x. So in my numerator, I have an x minus 1 and another x minus 1. And in the denominator, it looks like I have a 1 minus x that doesn't match the numerator. So I'm going to factor out a negative sign and then write that subtraction backwards, switched around with the x in front and the 1 in the back. Now I have common factors. So I can reduce those factors, and that negative sign that's left over, I'll just put it in the numerator with the x minus 1. And that fraction has been reduced. Looking at our third example here, x squared minus x minus 2 is divided by 1 minus x squared. Again, we're going to factor because of the plus signs, and these are all minus signs, but anytime there's addition or subtraction in your fraction, you really do want to factor. Break down the first term, break down the last term, no choices there. The signs have to be different, and the result has to be negative. So if I make the 2 subtraction and the 1 addition, I believe that works just fine. In the denominator, again, I have the difference of perfect squares, but when I break down the first term, I put it in the front is where I have to put the 1. And the last term that I'm going to break down and put in the back is my x. And the signs are different. One's a plus, one's a minus. Now in this situation, I notice that I have an x plus 1 and then I have a 1 plus x. But if you'll recall, the commutative property of addition says it doesn't matter which way that you add it, it'll have the same answer. So I do get to reduce these, unlike subtraction where it does matter which order you subtract. In the numerator I have an x minus 2, and the denominator I have a 1 minus x. If you leave your answer like that, that's fine, but some people will be very tempted to reduce the x's. So I suggest that you leave it in parentheses to make sure you don't do something you shouldn't.